Hello, good day. Welcome back. Today is day 5 and we are learning embedded system on ARM Cortex-M4. Today we're going to learn about real-time debugging in STM32F411RE. We'll see the steps that's involved in debugging. And these are all the sections we're going to learn today. How to create the project and debug the project in STM32F411, and how to configure the debug trace, how to set up the breakpoints and use the breakpoints, and how to set up watch points, how to use them, and how to keep them in your code. And also you're going to go through and learn about memory browser, and I'm going to show you what a call stack is. So these are all the things we're going to be covered today, and you'll be learning all of that hands-on. So before moving into today's session, I would like to tell a little bit about ourselves. I'm representing A2DG. It's a startup company started in the year 2023 by Anbukarasu brothers. That's my brother Alex and myself Arul. We both have 20 plus years of experience in the industry, and we would really like to share our knowledge and experience to you all so you can become a very good professional and have a better future. Our mission is to convey knowledge to at least 100,000 students and upcoming professionals out there through our online courses. And the good advantage is you can study at your own pace, at your own time, anywhere, wherever you are. And a little bit about me. I am Arul P. Anbukarasu, Arul Prakash Anbukarasu. You can call me as Arul or API, as popularly as I would like to be, but the time will tell, and I'm sure you will all make me popular. I have 20 plus years of experience in various industries working in Australia. I came here to do my master's degree. My master's degree background is VLSI and embedded systems. And since I completed my degree, I've been working here for the past 20 years. And my major industries that I work are in renewable energy sector, that's with solar and wind energy, power systems, that's lead acid batteries, network embedded systems, that's related with network systems, ATMs, TCRs, point of sales, banking automation systems, and smart parking operations. And my major area of expertise is in the second and third line, embedded systems, VLSI, and project management. I got to make a little announcement before I go into the session today. There is two different sections to it. All the videos that are available for you, I'll be uploading into my channel, so please tune into my YouTube A2DG channel. And if you continuously view 28 days of my course series, you are eligible to get a free e-certificate. But due to YouTube regulations, I can't keep the videos in there. I have to remove it after 2 or 3 days. So you get missed out. If you want to learn, you have to sign in and tune in every day to learn. But I sincerely plead you to join the internship program, where that's very much beneficial to you. It would lead you to acquire an internship certificate, and that's really a plus point when you hit the job for an interview, or also after you had that interview. You will see the difference because they take this 30 days course as a real hands-on experience count. So if you compare with the other engineers who's attending the interview or in the industry started with you, you will be sitting among the top of the list because you already gained this experience through these 30 days. So that's why I really encourage you to join the internship. Plus, you'll also get to access to all the course contents. You would be able to download all the PDF materials, the source codes, everything, and you can get access to it unlimited times. There is no set limit. And also you can access to all the course videos any number of times at your own pace. You can pause, you can start, you can watch as per your wish. And also if you get stuck at any point of stage, our backend team will be there to support you. So You won't get missed out. I'm sure you won't miss anything and you won't lose anything. Instead, you'll gain a lot from this series. So please tune into getting your internship membership, please. These are all the materials required. From today onwards, it would be a very good idea to have everything on hand so you can start to practice, because it's all hands-on from now. These are all the materials that I listed there, and if you contact Pantex Solutions, they would be able to help you to acquire all of that. And as a general rule, reading and listening to videos, you only get so much out of it, say like 10 to 15%. But when you actually start to practice on the board itself, you will get at least like 75 to 80%, and that counts a lot. So please invest on getting your hardware so you can start to practice. Okay, shall we get started? If you're ready, then we shall go, and I will show you what's in there on day 5, and I'll show you everything from the start with all those sections that we're going to learn today, and I'll go on one after the other so you won't get anything missed out. So get yourselves ready, go and get a cup of coffee or grab yourself a drink and settle in yourself, and we're going to learn hands-on today with the STM32Cube IDE. So let's go. And we'll start from here, creating a project on target using STM32Cube IDE. So connect the target board with the USB cable to your computer. If you haven't already downloaded and if you don't have the hardware, please watch my previous video, and I went through the whole instructions about how to download the STM32Cube IDE. If you follow that on-screen messages instructions, you would be able to download it. But if you get stuck in any point, just please bring that to the Facebook group, and I would be able to help you to install that. Okay, so let's get into the STM32Cube IDE, which I have to minimize this screen, and I'll share my desktop screen. Just 1 second. So after, if you have downloaded, then you will end up into a desktop icon that shows something like this. It's a STM32Cube IDE. You need to double click that and ask it to open. So this is the IDE that we're going to use for this whole series. So it's opening. 1 sec, so I'll show it to you. It's happening on the background, which you can't really tell. Once it's open, then I'll let you know. Okay, there it is. So it has opened after you double click that, and you get this workspace. Select a directory as a workspace. Now before doing your directory creation, you need to create a folder so you can keep all the projects in one location. So to do that, create a folder in your desktop to make it much easier. So I'm going to File Explorer, going to go to the desktop, and I'm going to create a new folder called ESD ARM Cortex M4 demo. ESD ARM Cortex M4 demo. This is just a name convention. You can call it as anything as per your wish, but I thought to be more precise, so whenever I see that, I know what I'm teaching you on that time. So this will help me really well to my extent. So that's why I named that. So hit enter and open, and create another folder here called target. This is where you're going to put all your project files into target. So create under folder named target and keep this aside. So now you're going to click on here, just left click on your mouse, Control C. You have to copy the link, or right click and copy. You can do it in two ways. You can do click there first with the left mouse, hit Control C to copy, or right click and click copy. Either way you can do it. So after you copied, you have to go back to the IDE. I'll minimize this. You need to create your workspace. So workspace is nothing but your project directory where you keep all your project files. So for that you need to tell the IDE where all your project files sit. So that's what workspace is. So you just come here and Control V or right click and paste, whichever it's easy for you. Control V, so I copied there. And you need to tick this box, use this as a default and do not ask again. So if you tick this, it won't ask again. And once you make sure you got the target ready, then hit launch, and this will start to open up the Cube IDE shortly. So it is loading on the background. Once it's ready, I'll show you. Because it has to initialize and it has to check a lot of files for the directory to link. So that's why it takes a bit of a time. But yeah, it is doing it, and you will see it in a second, which is now. Okay, so this is what the first point of view that you will see after you click the launch and you come here, and this is what you get, information center. In this information center you can start a new project, new STM32 project, or you can create a cube mx file, that's a .ioc file that's different for complex projects, or you can import a project from other IDEs if you're used to here, or you can use a STM32 cube example. So these are all the information center. So if you click on each and every one, it will tell you, like if you click on there, it will take you to a window that will show you all the information that you want to know about these particular tabs. But that will take a bit of a process because it takes a bit of a time to read through. It has got a lot to read, so we won't go there. And once it's ready, I will close the information center and I will start creating the first project in this STM32 cube IDE. But before that, if you'd like to have a bit of a 5-minute break, then please help yourself. Go out and do all the stretching exercises, and I'll see you back in 5 minutes, and then we'll get started. Okay, go and enjoy that break. I'll see you back in 5 minutes. See you then. Okay, welcome back. I'm sure you all enjoyed that break that you were after. You were able to stretch and do all sorts of exercise activities and got the energy back. I'll continue with where I left. As you are aware, you have to double click on this STM32 IDE and it will start to load all its contents, its files on the background. And it's loading. I can see on the background. Once it's loaded, I will show you and start from there. Won't be long. So it's still loading on the background. Just one sec. Sorry, close the STM cube ID. So every time when you start as fresh, it has to do a lot of internal checks. There you go. So there it is. So now I'm going to show you to create a new project, how to create the first project that you got your hands on. So all you have to do is go to File and New, and there are plenty of options in New, so which one to choose? So I will show you. The C++ project, if you choose and write your code, and it will generate the executable file, but that's only meant for this particular PC or for this computer. You can't use that code to use it in the target board, which I connected from the board to the IDE. So you have to choose STM32 project. Before going into there, let's check again to see my connected board via the USB cable is on the port list in device manager by doing just this device manager, and let's go to device manager and I'll show where it's connected with the target board. It will be under ports on COM, and I'll show you it's on ports. You will see STM microelectronics ST-Link virtual COM port on COM3. That's my targeted board. So yes, it's connected, and I can see all the lights lit up. It's on. Okay, now I'll show you how to create the project. So File, New. Since we are creating project on the target, I'm going to use STM32 project. So click on that. This will start to do a few things on the background, setting up files, all the necessary needed files for the project. And once it's ready, then it will move on to the next step, which is a target selection, where you're going to link your targeted board to the IDE. That's the next step. It's still thinking and loading on the background. So just bear with me one moment, please. Once it's ready, yeah, there it is. It got scared of you all, guys, so it started to work. That's good. So it's initializing to select the target. Once it's ready, then you will get the target selection window, and you can link your target board to the IDE. There it is. This is the target selection window. You can directly choose a microcontroller to write direct program to it, but today we are using the target board, which is Nucleo F411RE. How to choose that? So you have to go to the next tab as board selector, choose that, and then on the commercial part number, because as you know, after you buy the board, it will be labeled in the front, so you won't miss it. So I'm going to type the board name. It's Nucleo F411RE, and there it is showing. So click on that and come here, click on that, select. As soon as you click here and select, the next button will be enabled, and also you will get to see the features of the STM32 Cube IDE. It's documents and resources, its data sheet, and if you want to buy through IDE, you can also put through your purchase. So once you click here, just click next, and this will bring you to set up the project name. So I'm going to give, being the first project, example 1, we are on day 5, so I'll leave it at that as the project name, and I'll tick the box to use default location. This is where I link the workspace directory to the project, and these three options you need to be mindful of. So you need to select targeted languages as C, so we're going to write our code in embedded C. And the targeted binary type should be in executable, so you need to have an executable file to use it. And the third one is targeted project type. What type of project are you going to do? STM32 Cube has all the graphical interface and everything. That's for more advanced projects, but since I'm going to teach you from scratch, we have to choose empty. So I'm going to choose empty on this one. So choose empty, and then once you're done, click finish. This will fetch all the files, necessary files, and put everything in together. And as you can see already, the project folder started. So example 1 underscore day 5, and that will contain all the default files that generally links to this IDE, to that project. So by default, in the source files, there will be 3 files, which after it finishes I will show. So this is the project tree window, or a project explorer, where you can keep all your project related files in here. It has includes, which has all the header files. It has inc, it has src, where that's the main source folder, where by default you get all these 3 files: main.c, syscalls.c, sysmem.c, and the startup code. And there is a separate session to learn about startup files, but just to give you a brief, startup files are the ones that run before your application code to make sure everything is set properly, so they do that bit, but I will elaborate that as in a different session. So you don't have to worry about startup right now. So all you have to do is now is to double click on main C and go to the editor window. So do the double click, and in a while this will open into the editor window. This is where you're going to write your, or type your code, I should say. Type your code in your editor window. Being opening first time, it will take a while to see through all the checks, and there it is. So this is the main C program, and this is how it looks. All these in slash with stars, these are all for nodes, so you don't have to worry about. This is for authors. Like when you're working in real big projects, this really helps, because it tells who written this code and who is this author, and what it is all about. So just a bit of a small introduction to the code. So it is really necessary to keep, but if you think it's too much, then I can delete it, but for the moment I'll just leave that up, because we're going to concentrate what's down here. So because I'm going to teach you from scratch, I'm going to delete everything inside, and I will show you from scratch. Okay, so I deleted everything, and now I'm going to show you the first step, or the first process in the example 1. ARM Cortex-M4 allows printf style of debugging. What is printf style of debugging? I'm going to show that to you. As most of you will be familiar from your C programming days, printf is the one you use in your code to view the outputs in the console itself, in the console window. So this is the console window where you will see the status of your code, and this is your outline window where as soon as there is some changes, you will see the added files as I progress, as I type. Okay, let's start on with I'm going to write my first printf, and always remember always remember that semicolon in the end. That's very important. And we're going to say hello to the world. How surprising. Okay, so every function should return with a value, so I mentioned that here. And once this is written, then you can go and right click and build this project just to get a start. Right click, build project, and this will compile and gives you the status in the console window. So this is the console window, and you will see all the different files, NAGB, EABI. So if I go here, I can give you or show you some extension .elf file. .elf is the executable linker file which you needed when you want to burn that into the target board, which is what we are after. We need the .elf format. So it's checking all the code, and it's coming up and showing me the status as 0 errors and 2 warnings. Because we're going to do the debug mode, and this is about real-time debugging, so we need a bit of help other than just writing a printf statement there. So what is it? If you go back to the presentation that I shared with you today, you got to use the debug trace so that you can start your debugging in your code. So you can get this piece of code from the STM microelectronics or from the data sheet. So it is readily available, so it's nothing new. Copy the whole code. You can do two ways. You can do a right click here and then copy and then paste it in the IDE, or if you're more versed with your keyboard, you can hold Ctrl C, that will copy, and go back to your IDE, and you need to go on to syscalls. This is syscalls. This is where all the header file lives. So this is where you're going to paste the debug code so that you can debug your writing code. So under #include all the #include files, Control V, paste that copied code from the presentation, and this is the first step done. So that's good. So now you're going to include this function. You're going to call this function to write and send characters. So Control C, and you have to scroll down to go to int_write. What you have to do is, to start here, you need to comment this line. You are not giving input output through put character, so you need to, oops, sorry, I didn't mean to do that. Just go back, int write, go here, click /, will make that line as comment. And here we're going to call the function that we just pasted there. So Control V, and we are declaring the pointer, so it is the pointer, and don't forget that semicolon. Save it and do another build. Right click, build project. This will check both the files and give you the status of that printf statement that you just written. Okay, still it's showing 2 errors, but not to worry, that's not a problem. 2 errors and 1 warning, so we will reduce that. But as a programmer, it's always nice to see that when it lights up with error, that means you're going to learn something new. So something happened, you're going to rectify that. And how you're going to do that, you have to go to that location where it says the problem is, then you just go there and make the following comments and change everything, and then you can do wondrous things. Okay, so it's showing an error with the implicit declaration of ITM send character of pointer plus plus with the, okay, I have to check the previous code what I written here on the top. Void, okay, just one sec, I'm just making sure I haven't missed anything while I copied. There is, I just cut this and pasted instead of copy paste, so that's one of the problems. So copying this function name, going back to the IDE, you got to declare the function, yeah, and then save, and once again compile and build the project. So this will eliminate that error that we saw when you were watching last. It's checking the background and all the files, so it's checking and just about to create .elf extension file. As you can see, the build project status goes here, so it has to go through all the way to 100 to see the status. At the moment it's 26%, so just be a little bit more patient and you will see that, yay, there it is. So it's 0 errors and 0 warnings, but still in the console window we are not able to see any output of saying that particular word what you typed, hello world. Why is that so? Well, all you experts may be knowing, but it's my duty to tell why it is not showing. So when you use a printf statement, you have to include that library file. Yes, please don't forget the library file, which is hash include stdio.h, and save and run again, which means build and compile the project. So build, right click, build the project. So again, this will go through the project build, and when it hits about 26%, it will start to show the ELF file, and it will give you the status of the errors and warnings. So that's all well and good. So still you can't see any output. So still we are in the C++ perspective. Now I'm going to show you how you can set the debug settings. You have to set this before you start to debug. So to start the debug, you need to get this first, 0 errors and 0 warnings. So that's a good sign. So that means your code is ready, error free, no warnings. Now you can go and debug and check more internally. So to do that, example1 underscore defi, right click, this time choose debug as and go for debug configurations. So click that. Debug configuration window will open. So go to the very end where it says stm32c/c++ application. Double click on that, and that will open the configuration window where you have to create a couple of settings. So by default, when you click on that, you'll get the name example1 underscore dev5 debug, and the project name is we are working on the project 1 example1 dev5, and by default that links with the .elf file. To show that, because as you remember, we created the target earlier as ESD. I'll show you desktop ESD ARM Cortex M4 demo. You go in there, and we created this folder target, and we created these files. So if you go to example1 and debug, and there it is, those 3 files will be generated after you click on build project. These 3 files will be generated, but before then nothing will be there on. So you need to link this example dev5.elf in the application. That's what you see here, debug/example. So that's what it's done. So once that's done, then go to the next step, which is the debugger. Click on that, and you have to do a couple of changes here. Go to the interface and choose ST-Link. That's your target board, so you need to choose ST-Link. And then for the console window to view your output, you have to select the serial wire viewer and click this enable, and that will set the output parameter so you can watch your output in the console window. So once you've done these 2 steps, you simply go here and click apply, and then click on debug. This will tell the IDE that you are moving from C++ perspective window, which is this, to debug window, which in a minute you will see. It's doing its thing, so it's launching debug mode. It's on 4% right now, so it has to link and check everything as it progresses. So a bit of patience will won't go astray. So 15%, it's still doing its checks. 70%, 79, still going and still checking. 79, still going, and it's waiting for the debugger connection on 89%. And here it is. So it will ask for it to switch from C++ perspective to debug. So click switch, and once you hit switch, then you automatically see this different format of files, which you will see in a fraction of a second. Yes, it finished its debug mode. So we are in debug. How you can tell, as you can see on the right 2 side, so that's the debug window. When you click on switch, it generates that and brings the debug window, so you can see all these newly added variables, breakpoints, expressions, disassembly, register, everything, and this will be generated in debug, and that's the C++ perspective. So this is how you get the files in and how to get your debug mode activated. So we are ready, and that's the debug window. That's where you can see all your files. So now I'm going to enable how to view your output. So to do that, you need to go to window, go to show view, and you need to go to SWV, that's serial wire viewer, and in there you have to choose SWV ITM data console. ITM stands for instrumentation trace macro cell data console, which is nothing but to trace ports. So click on that, then you will see this extra tab added in the console window. It's where you're going to view your output. So click on start trace. So this will start to trace your output, but before doing that, go and configure the trace. So one tab in front of it, click on that configure trace, and it's linked to port 0. So you have to enable this port 0. Please remember port 0, and then click OK, and we are all set. So we started to trace. So now let's see what happens. So these 2 are very important buttons in your debug mode. So this allows you to run the program in debug mode. This allows you to go step by step, meaning line by line, and this one goes step over, meaning it can skip one line and go to the other. And there is another option called step return, which skips entirely the whole function and goes out of the function, so which I will show you when that button highlights. So for now I'll click on resume to run to see what happens. I clicked on run, nothing happened, so still we are not able to see the hello world. Why? Okay, many of you would know, and if you're an expert you already know why that's happening. It's because whenever you start to generate a printf statement, all the messages sits in a buffer location, which means they are in a temporary location, and you need to flush them out to show it on the console window. So in order to do that, you need to use f flush std out. So once you do that, you will be able to see the output on the console window itself, but because I included this new line, it won't show the output straight away. So you need to kill the project and then rerun it. To do that, you have to terminate and relaunch. So click this option, terminate and relaunch. This will come out of the debug mode and it will switch to C++ mode, check for errors and warnings again, and then it will ask you to switch to debug mode. Then on the debug mode you have to go back again and click the run button, and that will show the output on the console window. So bear with me for a few more seconds. It's on 4%. Okay, the target is set with .elf file. Yeah, that's a good sign. So it has 0 errors and 0 warnings, which means it accepted that line of code, and it's saying it's ready to be used for debugging. So let's wait for a couple of more seconds. Sometimes it automatically goes to the debugger. Yes, it does. And if it doesn't, then you can go to debug. So this is same as before. It asks for you to switch from C++ perspective to debug perspective. So this is what I did. After you click switch, you get all these extra goodies we call variables, expressions, breakpoints, registers, live expressions, everything it's there. And also the SWV ITM data console, everything in there. We already set this, so we don't have to do. So because we put that f flush, all you have to do is go back here and click run again, which is resume. So as soon as you hit run, look what happened. Magic. Yes, you have written your first code and you have seen the output, and it's right there. And voila, you know how to write a piece of code and how you can bring your input to the output. So this is all about programming. So what you write inside the function code should be appearing on the console. So this is all about programming. How exciting is this? I'm super excited. I hope you are as well. And I'm sure by the end of 30 days you will be a better professional than where you are. So stick by me and I'm going to show you more. It doesn't stop, but I'm so excited to see first time hello world. So I couldn't stop myself to break in to show the things, but yes, that's a good start. So now you can see hello world. So far you learn how to create a project, how to eliminate all the errors and warnings, and how to set up your SWV ITM data console to see the output, and how you change from C++ perspective to debug, which you get all these options in there. Now I'm going to add further along to show a bit more about putting a loop in there, to show you what happens if I create a loop in. So just bear with me for a sec before I start doing that. So you got to int main of void, and I'm going to include a loop. A while loop. Always make sure that if you open curly braces, make sure you also close, otherwise you'll get plenty of problems by not doing that. So once you've done that, then go to save, build the project again, because this refreshes and put everything back in track, and then you have to go to debug to show you what happened with this while inclusion, the loop, while loop. Yes, so I'll show that in a tick. Please bear with me. Okay, it did the build, the compilation, so it come as 0 errors and 0 warnings, which is happy that it accepted the while loop. So now let's go to debug to see and view our output. So to do that, again you need to go there, right click and debug as, and go to debug configuration, and again the ID will ask you to switch from so before it will ask which program you want to debug. So we are on example 1 def. Choose that, and then you already set these two tabs, you don't have to worry. So click on debug. This will take you back to debug window. So now the ID will ask you, would you like to switch from C, C++ to debug, and you have to click switch, and that will take you to the debug window. So it's nearly done, 89%, nearly done, waiting for debugger connection. Debugger connected, 93%, still detecting. It's about to connect and ask you that message. Just bear with me. Okay, I don't know what happened there. It didn't ask me to change or switch. We are already in debug mode, as you can see. So now all you have to do is open this console window and leave it open. You already set your configure trace. So all you have to do now is to check what this while loop does. All you have to do is go in there and click. Well, I'll show you step by step. So you go into step into, one click, you wait, and after a few seconds, if nothing happens, do another few clicks and see what happens. So now it executed the hello world. So if I do a full run, see what happens. If I click resume and run, let's wait. Voila! So this is what the loop does. What is actually a loop? A loop is something continuous that never ends. It keeps going. So until I ask to stop, it won't stop. So it keeps printing world hello, hello world, world hello. As you can see, it's not really even typing, not grouped as a word. It's showing us world hello and stuff, hello world. So there is a space missing, and that's about the \n line, which I didn't use, so that's why you see that, which I will rectify that in the next program that I'm going to show. So far I have shown you how to create the project, how to change from program mode to debug mode. Program mode is nothing but C, C++ perspective mode. Debug mode is where you come and see your output at the console window on the SWITM. So this is the difference between just one printf statement and the use of the loop in here. So I just wanted to point out there. and with this I may be able to break and give you 5 minutes break, and when you come back I'll show you the second section, and we're going to learn about call stack and watch points. So please go and enjoy that 5 minutes break, and I will see you back in a tick. Okay, welcome back. I'm sure you all enjoyed that long break. Now I'm going to move into showing you the next example. So far we have covered or you have learned how to create a project, how to set debug options, and how you can enable your console window, that's SWV, to see your output. Now I'm going to include more code in, so you'll get more in-depth debug experience in here. So to do that, I'm going to just copy this project and I'm going to use it in the second project. So just paste it, and it's asking for a different name because it's going to be a different project. So example 2, you're still on day 5, and then click copy. This will generate and it will copy all the contents from example 1 and it's moved to example 2. So go to source code, source folder, sorry, I pressed it too long. So going to main, going to syscall. So that's from example 1, so I'm going to close example 1 altogether, not to confuse you. I'll close that window, and also you don't need this window, so I'll close this as well. Okay, so I already copied the debug files in project 1, so you don't have to redo it again, and also did the changes in int right for sending characters, so that's done, which is good. So now I'm going to go into main program. I'm going to include more lines of coding, which you will see in a while, and this will give you more in-depth debugging options. So I'm on int. I'm going to create 2 different functions. Int a, int b, and the next function is int sub int a, int b. So I declared the function. Now I need to call the function, and I need to say what the function is supposed to do. Int a, int b, open the bracket and close. What is I need to store the results, so I'm declaring the storage location and what add supposed to do. Add should do a plus d and return sum. Yeah, return sum. Just give me a second, just checking. Okay. A plus b. So likewise, I'm going to do for the diff int sub int a comma int b. Then int diff, and what the diff supposed to do, diff is a minus b, and store the result in diff. Okay, so we done that bit. Now I'm going to do some changes here. Add two numbers, and what that's supposed to do. So sum equals add of a comma b in here, and this will add the value, and then I have to print the stored value. I have to show in the result. So doing that, printf sum of two numbers being integers. I need to use that percentage of d backslash of n, and which result you want to see. So that's for print. So sorry, copied it the wrong space. Space back. Okay, so that's sum. So now you got to do the same for the diff, which I will include in here. Sub two numbers. What's the diff has to do? Diff equals sub and a comma b, then printf diff of two numbers is, and which variable is diff. To include the local variables in here and initialize it. So I'm going to do a minus b, so I'm going to give a equals 10, b equals 7, then sum comma diff. So I declared all of that. that diff, okay, std out diff sub comma b sum and a comma b equal 10 sum and diff return. Okay, so that's pretty much I have to show, so I'll save this project and compile it. Save, right click, build the project. Building up to 19%, just bit more patience, just doing all the internal checks and creating all the listed files. So that's happy with the included files. So now you got to set the debug option. So right click, this time choose debug as, go to debug configurations, and this time you're going to configure example 2. By default it comes as example 1, but change that to example 2 and example 2 there, and you got to browse and you need to link example 2 ELF file into the application where you are targeting. So clicking on browse will take you to the folder where you created in the desktop ESD ARM Cortex M4 demo. Inside the target, inside example 2 day 5 on debug, if you see it's on example 2 d5.elf. So open that and link that to here, and on the debugger make sure the ST link is enabled and the serial wire viewer is enabled. So once that's done, then click apply, and then click debug. Apply debug. So it will start the IDE to do the conversion from C, C++ to S, and it will change to debug options. Example 2 debug. Zero errors, which is good. We'll go into SWV ITM. It still haven't done the switching, so just wait a bit, patience. 89%. Waiting for debugger connection, and now it will ask for us to switch. %. Yeah, it's happy, and it created the main function in the debug. Okay, so now let's see the output. So we already created this and enabled port 0, if not enable port 0. All you have to do is go here and click the program step by step. So first click, it executes, checks for printf statement, and second click, it executes and checks for the second flush statement. Now it comes to the add two numbers, and it will add the two numbers, go to the sum, and now it's going to display what will be the result of two numbers is. It's going to print sum of two numbers, so which is 10 plus 7, because we're given so much printf statement, so it has to check all of that, but the result is sum of two numbers is 10 plus 7, which is 17. That's what we want. So I'm going to go and hit resume run, the full run, so it will give you the value. It will keep the value of 17 and 3, 17 and 3, 17 and 3. So there you have it, the second program that you can see the input value and the output, it's there. So I'm going to just stop that, and I'm going to give you more in depth about this code that we just written. So I'm going to stop this by just clicking stop. It will stop the debug option that completely comes out of debug. So when you do that, it will come out of it. Then you have to go back to debug again. Instead of that, you could actually do terminate and relaunch, so you don't have to do this again. I'll show you in the next window. Choose die 2, yes, and click debug. Yes. Okay, it's not detected because we stopped, and it will ask to debug. Debug configuration. Make sure it shows that example 2 d5 and debug. And wait for the launching example to finish 100%, so you can get the second program there, and I'll show you to assess and see the values of variables and how to see the expressions and to set breakpoints. Sorry. Yeah. Now click switch. So it's switched, and you know when you click run, you are able to see that output. When you do step by step, it prints, it executes step by step, and then it gives you that printf statements. By clicking on step by step, it goes every time, goes inside the function, checks for it, goes out of function and checks for it, and finishes. So that's how it operates. So as you can see, there is plenty of other windows that's open. So click on variables, what it is. If you just click on the variables, whatever you written, it's all already shown there as a and b, sum and diff, and the values of 10 and 7. So these are all the variable analysis of the ones that are given, and this one shows you in binary, in hex format, and different formats. So the other one next to is expression. So if you want to read the value of the variables, for instance, if you want to read the value of a, you go to expression, add new expression. You need to get the address of that expression. So ampersand a, and then hit enter. You get this address. So click on this address and copy this address. Control C or Control V. And now I'm going to show you how to view memory browser. Windows, show view, go to memory browser, and the memory browser added to your console window. So you copied the address of variable A, you come here, paste it and hit enter, and there it is. So the value of A is 10, as you know in hex it's A, and that's the address of the variable A, and that's a value. So that's how you see it. So if you want to see the next expression, for example, say if you want to know the location of sum, value of sum, so hit enter, it will give you the address. So copy that address, come to your memory browser, you paste that and hit enter. That will automatically give you the location. FFEC got 17, so 11 and 7. So it's showing us 11 and 7. Yeah. So likewise, it will show all the results, whatever you want to see. You can check from the expression and you can see the values, values of it. So this is how you have to see the memory browser, and you can actually see the value of your variables and its address by doing this expression check. And if you want to check your assembly language, and you can do this by clicking on disassembly, and disassembly will give you instruction stepping mode. That means you can debug in assembly mode step by step by using this instruction cycle. Okay, so now I'm going to show you how to set breakpoints in your code. So you written a long piece of code, now you're going to set breakpoints. So I open the breakpoints. All you have to do is you can keep up to 7 breakpoints in your code. So go to that line wherever you want, double click on that line, and this a small tick mark appears. So the execution will start from there. And the second and the third, fourth, fifth and sixth. I'll stop at that. So now when I go to run step-by-step mode, whatever these set points that you triggered, so these are all breakpoints that's added here. It shows where and which you created. So line 22, line 25, 32, 39, 47 and 54. So I'm going and running my program now. So what this actually does is it runs the program and then comes and stop at the first execution point. That's the first breakpoint. So then you start again, and then you can see this is the call stack window. So whatever breakpoints you set, accordingly under the thread you will see those changes adding up to the pane. So I keep clicking, step into, it's checking and it's going to main, and I'm going to step over, which is the next one. I'm skipping that. See, as soon as you click on step over, you get the add-on section. So this is the call stack where whatever call you make in the function, it keeps stacking up in hierarchical form. So that's why it's called as a call stack. So you click step over and the next step is added. So if you want to completely come out of this function loop, all you have to do is click step return. So that comes out of that code of that function and comes out to the next breakpoint. So the breakpoints in the code you use to set, it stops the execution, line by line execution, and it stops at that point, and it makes you to take a moment to think for you to do what you want to do next. So that's basically it. It stops the program and you can start to do your modifications on the code. So this is about, so far we have created from the project 1 that we learned about creating a project, You learned about setting up debug options and how you enable SWV to see your output, and also you learned about switching from C++ to debug perspective. On the second example, you learned about including more operational functions in there and visualizing breakpoints, how you set breakpoints, how you keep breakpoints, and you learned about call stack, and then you learned about variables and how you check the expressions by %a, %of, and also you learned about the memory browser, how or where the value of the memory browser is. So in the next example, I'm going to show you what is a watch point and how you want to set the watch point. So I give you a few minutes break, so please go and enjoy the break, and when you come back I'll show you the watch points, and there is not much to go for day 5, so I'll be quick as I can. Thank you. Hello and welcome back. So far you learned about creating a project, creating how to set up your debug files, how you're going to switch from C++ perspective to debug, and also you learned about call stack, you learned about breakpoints, you learned about how to see the value of your variables, and you also learned about the memory locations of where all your variable values sit, and you also learned about how to view your output through SWV. So in this session I will show you to set watch points and how to keep watch points and what is watch points. So to do that, I'll simply copy again to create on the project. So I just copy and paste it here. It'll ask for what name, so I'm going to give it as an example 3 under day 5, and I'll just copy. So it generates and it compiles and copies an added file to example 3. 62%, so it's finished. I'll close all of this. This is for example 2, which I don't want you to get confused. So I'm now going to explain to you about watch points, how to set watch points, etc. So to do that, I'm in example 3, main function and syscall file. Because I already you remember we already copied the debug files from the presentation on example 1, so you don't have to do it. So that's why I went the easy way, just to copy and create another project. So that saves me to go back and copy it again, because those debug files, it's already in there, copied and ready to go. So the debug exception, and if you scroll down, you will see the int right still there. Sorry, I went too far down. Int right, yeah, there it is, int right, and itm send. Okay, so now I'm going to show you how what is Watchpoint, how you set watchpoints. We are in a debug mode. So because I created a new project, it's always best to compile for errors. So always build your project to get error free. So now it's happy, it's showing as error free, which is what we really want. And now I have to change that to a debug mode, which is debug as, debug configurations. I'm switching from C, C++ to debug operations. So, and now here we have to change to example 3, because we're going to play with the third example. And also you need to link the ELF file from the third folder that we created inside the target. If you go to example 3 and if you go to debug, it will be down on example 3 def5.elf. That's what we want to link to, and link there, and make sure in the debugger you selected st-link and your output window enable. Once you've done that, click apply to make all the changes and click debug. So it's all set, and you can see the expressions, everything changed, which is all good. So if you want to remove all the breakpoints, all you have to do is do a right click here and remove all. This will remove all the breakpoints inside the program which you set earlier. Remember, we set 7 breakpoints and now it's all gone, so it's all empty. So now I'll show you what is a watch point and how you can set and keep watch points. You have to come to these 3 vertical dots, click on that, that brings you view menu. menu, sorry, and go down, and there is an option called add watchpoint, C++. So click on that, and this will ask you what you want to watch. So before doing that, what is a watchpoint? Watchpoint is nothing but you creating a condition in your code and asking the IDE to watch for that particular code or that particular expression to check whether it behaves the way it's supposed to be. So in order to completely understand that, so I'm going to just include a small inclusion in the program, which you're going to see here on the main program. I'm going to, sorry, I'll cancel this. I will show this first. I'm going to include this variable for you to see. So I'm creating a variable called int data. Okay, so I created that variable and I leave everything as it is, and now I want to see what happens when my data gets read. And sorry, I think I might have clicked on a few buttons, so it's taking. Okay, it's data, so I'm going to make sure what it's going to happen at say after sum, printf sum. So I'm going to set my data condition here, data equals data plus 5. Okay, so I'm going to save this, and I'm going to include now in the menu, view menu, add watchpoint. It will ask me what to watch, and I will say yes, I want to watch my data, and you click data, and when data is written, apply and close. So you don't have to write any condition. So apply and close, and you come here and start to run your program step by step. So it executes step by step, it executes, I say now, and watch what happens when it comes to that watch point. So it executes line by line, line by line, line by line, line by line, line by line. As you can see, it also changes in the call stack as well, as you might have noticed there. So now comes the watch point that I just created. So it checks for the variables, it executes the next line, then it goes to the sum, it executes that line, and goes again to the next function, it executes again. So likewise it keeps adding on and keeps going until it hits the data that I created in. I'll close this to confuse you. So this is where I have written and saved. So we are in Project Explorer and debug. And run to show you what happens with the watch point now. So it start to execute. As you can see, the previous one, it added the sub. Okay, the call stack, because it's been connected with the sub, it goes to the sub, and it comes to the sub, it goes to the printf and it goes to the diff straight away, and it prints the value. The expression data until the condition that what you are given here, the condition, I will check whether I included the condition or not. So I'm going to remove that, remove, and to set watch point again. What I want to watch is data, and what the condition is data equals data plus 5. So apply and close. And full run. And terminating and rerun with the expression that I just set. So what it's supposed to do is it will execute line by line, and when it comes to that condition check, it's Watchpoint, it's also a breakpoint, but it's with conditions. You're going to set some conditions to check, and that's the difference between the breakpoint and the watchpoint. So example 3, debug. It's coming on to debug. Just one sec. Okay, it compiled and without any errors. That's a good sign. So now once it's completed 100% here, it will ask us to switch to debug, which will happen soon. So there, waiting for debugger connection. Yes. And then you ask it to switch. You switch. And then you just go and do a step-by-step run. Once the device that completes 100%, then it will be ready. Yeah, that's happy. Sorry. Okay. Sorry, I clicked too early, so I had to do again, change to debug mode, debug configuration. Make sure you're debugging sample 3, day 5. You click on debug, yes. No link detected because I didn't choose, which is okay. If it says no ST link detected, you have to do it again. Go to program, right click the project, debug as, go to debug configurations, and go to the debug configuration window, choose example 3 and debug. This will take you to the debug window. And then switch to perspective, debug perspective, sorry. Waiting for the connection. 93%, yes, it's loaded. And You remember we have set on line 51 the breakpoint, which is the watch point actually we set, and we given a condition. So when you on here, when you click the run, it will go exactly to that point. So click run, it will start. Resume. It goes to the next step. And resume, I'll go to the next step. So what it actually does is it checks every time the condition of 17 and 3, and it will do that until it hits the watch time, which is the data, and it will stop at that time. That's the expression I have set. I'm going to remove that expression, remove all, set one more time. Another watch point. I want to watch my data, apply and close. Okay, so when you run, it goes directly to that point. So now, as you can see, before now I purposely didn't set my breakpoint, so I was showing you the execution of the sum on the diff, but as soon as I hit a breakpoint with a condition that I want to monitor, the cursor immediately goes to the condition where I created the watch point, and it tells us, hey, you set a watch point and it's there. So it's just letting us know. It's like a reminder, if you like. So if you still keep running, then it will go to the next step. It will keep coming back to that because there is a watch point, so that gets a priority. So the ID won't do anything unless you change the data condition, and it will stop. So this is what watch point is. Breakpoint is to just halt the program, and if you want to do any inclusion or any changes, that's where breakpoint comes in handy. And also on a long 1500 lines, 2000 line codes, breakpoints really help because it takes you to that point, and you can analyze to that point, and you can clarify. Watch points is where you create some conditions and try to match with the functionality, and you check that way. So this is how you do breakpoint and watch point settings. And that is for now with the project. So let's go back here. I have a few more things to show on this presentation. So that's the debug trace that you use to connect it there and change the right function. So this is where you have to change the ITM send, which you've seen, and debugging options. So these are all the debugging options you learned: serial wire viewer, single stepping, stepping over, and stepping out. And the breakpoints, disassembly, you learned about call stack, expression and variable windows, memory maps, browser, data watch points, SFR windows. I'll show you more about SFR windows when we go in depth into the other projects and other basic features of IDE. So you started with the importer, IOC editor, you went to see the browser, the hierarchy, and you see the brace navigation, which is nothing but the open loop and closed loop, and the call hierarchy, which is another form of call stack. And you clicked on SWV to check the output console window through your ports, which is that, and few of the different things where your SWV gives you options. And the build analyzer will show you so far what you build in the RAM, memory, and in the flash, which when we did the console window, there is another build analyzer that shows your memory locations, your memory regions, etc. The binary change, if you want to see the value of your variable value, you can go to radial and change this setting into binary, and you can see the binary change. And this is a data trace. So these are all the debug features. So in summary, what we learned today is to create and debug a project, and you learn how to include the debug trace. That's copying those piece of code, put it into your syscall, and that's the debug trace that starts. And you learned about what is breakpoints, how to keep breakpoints, and how to set it. And as well, you learned about watchpoints, how to set watchpoint and how to keep it going. And you learned about how to view the value of the variables inside memory browser and what is a call stack. So that moves us to the next section, which is the mindset. As I said earlier, it's not only skill set that you need to develop, you also need to develop your mindset as well. So today's mindset lesson is about the word itself, the word, meaning what you're going to say that has a lot of power. The word, whatever word, it has dual personality. It can create a better thing or it can destroy completely. So the word, what you use, what you going to speak, think before you speak and monitor it, because once you thrown out the words, it can't be taken back, and it would hurt a lot of people. For instance, if you're talking to your parents and to your spouse or anyone, excuse me, that may hurt their feelings. So that's why before you speak, please think through and please see what you want to say. That's what basically is. And I would like you to record 100 small clips on your phone about I am affirmations, like I am really a confident person. That's an affirmation. I am able to do my exercise for today. That's an affirmation. I am able to avoid junk food. That is an affirmation. So like that, record 100 on your mobile phone and listen to them. Once you start to listen to your own voice, you know what you want to do, and that creates in your subconscious mind, you want to link, and it takes you further to get into that section and area where you can go and develop your attitude, and also it changes your thinking altogether. So this helps in a lot of areas. So please do that, and please post your recorded affirmation messages in our Facebook group, so we can also learn from each other and we will motivate and move on with that. So again, please don't forget to do the involvement that's related to mindset. Please write down your top 10 goals and write down top 10 ideas to achieve that goals of the top 10 goals. And please do spend at least 30 minutes to do some sort of activities, physical activity. It can be exercise or a gym workout, or you can go for a long walk. And also please do set yourself 15 minutes of prayer or meditation, and 10 minutes set aside to actually visualize that you actually achieved those goals. So spend 10 minutes on that, and spend another 10 minutes to plan for your day, for your next day, for the next week, etc. And 2 hours of learning a day, it's all you need for you to grasp, and you have to be more powerful in that learning from your lecture notes. And all these will be point systems, so whatever, it doesn't matter how much you get, please post that in the group so we all know, and we will learn each other and we'll motivate each other. But the end goal is I would like everyone to hit 10 out of 10. So please follow this, and please be honest with whatever you're doing, and please post it in the Facebook group so we can also learn and go from there. And there are few goodies coming your way. There is a combo internship which you can get from ARM Cortex. There is a different series that's running up with has ARM beginner, intermediate and advanced, and also there is a bundle combo that's coming up, which you can see all this, it's all coming your way soon. So Stay tuned with us and you'll hear from us about these lovely deals. And I once again say a big thank you to all of you who are here today, and I'm sure you are useful now and you are more confident to use the IDE to do various things. And I thank you so much for your patience, and have a lovely break from your deserved screen. So go out there and enjoy the break. I will see you in the next class, and we will learn more about in deep about the next step in the Cortex M4 series. So thank you. It's Arul Anbukarasu signing off on behalf of A2DG. Bye for now, and it's Huru from me. I'll see you in the next lecture. Thank you.